This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic. All right, we're going to solve this multiple angle trig equation. Now, it doesn't look like a multiple angle, but you see this x over 2? You could think of that as 1/2 times x. In other words, it's not just x. We usually just call that a multiple angle. So we want to start by writing the equation. And then what we need to do is combine these like terms. See the sine of x over 2, and over here you have a minus sine of x over 2. So what you want to do is add sine of x over 2 to both sides. And be careful here, that does not mean the sine of x, that means the coefficients are what you add together. You get 2 sine of x over 2 is equal to square root of 2. Now we need to solve for the sine of x over 2, so we need to divide both sides by 2, right? So that cancels. That cancels. And we've got the sine of x over 2 equals square root of 2 over 2. Now you should recognize this as a special value for one of the special angles. Where is the sine square root of 2 over 2? And if you don't recognize it, because it doesn't look like just a square root where you're used to seeing it, you can rewrite this by multiplying the numerator and denominator by square root of 2 and simplifying it, which is 1 over square root of 2. So if you're used to seeing things as 1 over square root of 2 and this throws you off, then notice all I'm doing is rationalizing the numerator, and then of course I have to cancel the 2's here and get this. But hopefully most of you are comfortable enough. You're saying, where's the sine square roots of 2 over 2? And that's, at the 45-degree angle. But we have to find all the values here. First of all values. Then we're going to have to decide how to find the values for x just in between 0 and 2 pi. Okay, so where can x over 2 be? So the first thing is to think of where all the places that can happen. Where is the sign going to be square roots of 2 over 2? Well, it's positive, right? And either you memorize it or not, but that's these two places, that's where the sign is positive, right? So we've got two different places right here and right here. We're asked to write these in real numbers. So this is pi over 4. And remember all the multiples of 2 pi, right? I'm sorry, we're going to add on multiples of 2 pi, so 2 pi k. Those will give us all those solutions. So that's one possibility. I'm going to make this a little bit smaller because we also have, what else? What's this one over here? That's 3 pi over 4. And again, all the multiples. So if we were asked to find all the solutions, I still have another step to do here because I haven't solved for x. So we want to do that. Multiply everything by 2. So I have 2 times x over 2, 2 times pi over 4, 2 times 2 pi k. Same thing over here, 2 times x over 2, 2 times 3 pi over 4, 2 times 2 pi k. So we've got that x equals pi over 2 plus 4 pi k. And over here, or we've got x equals, all right, can we cancel here the 2 and the 4? That's going to give you 3 pi over 2 plus 4 pi k. So if we were asked to find all the solutions, and that's what you do first, figure out what all the solutions are, and then we're going to list the ones in the right interval between 0 and 2 pi. So that's where we're at now. Okay, so if we take pi over 2, that'll be the first one, right? And then if I add 4 pi, oh, I'm already over 2 pi. So that's the only one I can get from this first equation. All right, let's look at the second equation. I've got the 3 pi over 2, which is certainly less than 2 pi, so that's listed. And again, if I add 4 pi, I'm already over 2 pi. So in this case, there happen to only be 2 solutions. Little hint is, usually if you have x divided by a number as opposed to 2x, you might have half as many solutions as if you were just solving for x. Or you might have, less solutions anyway, fewer solutions. All right, so for this answer, for this problem, since we were only asked for the solutions in 0 to 2 pi, we're done. And you can always check either of these in the original. Let's go ahead and check pi over 2. So here's the original equation. Now, you could write that as pi over 2, but remember, x over 2 is a half times x. So I'm going to write it that way, of half times x. I'm plugging in pi over 2 for x. And then we're just going to simplify this left-hand side. The sine of pi over 4. And the sine of pi over 4 is 1 over square root of 2, or square root of 2 over 2. Right, same thing. All right, what about the right-hand side? So we're again plugging in, I'm going to think of this again as 1/2 of x. So you have square root of 2 minus the sine of pi over 4. So I have square root of 2 minus, now what's the sine of pi over 4? Well, that's square root of 2 over 2. We just figured out over here, right? So I'm going to write it that way. Square root of 2 over 2. And now I have a subtraction problem, so I need to have a common denominator. So I could multiply this first term by 2 over 2, and that would give me 2 square roots of 2 over 2 minus square roots of 2 over 2, which is, all right, what's 2 square roots of 2 minus 1 square roots of 2? That's just square roots of 2 over 2. So it does check. So that's what your check would look like if you checked it. And then, of course, you could do the same thing for it, putting in 3 pi over 2 for 2. That's the only way you know for sure whether those are actually solutions. So at least we know that that one worked, and if you do try 3 pi over 2, that's also correct. So this is the solution for this problem. This is your Math Gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic.